Hi, this is Mrs. Kidman, and in this video, we're going to be discussing periodic functions. Now, there are a bunch of definitions that kind of go with periodic functions, and we are going to go over some examples. However, this is your heads up in this video. As you are taking notes on periodic functions, make sure that if you don't get the definition in the time that we finish talking about it, that you pause it, write it down, and keep going. If you need to go back and re-listen to it again, that is totally fine. That is a great note-taking skill. So we are going to talk about something called periodic functions today. Now, periodic functions are functions where the same pattern is being shifted over and over and over again. It's kind of like a copy paste sort of situation where we take a pattern, whatever it is, and we put it on our graph, and then we copy and paste it. Notice how in this pattern here, the size doesn't change. It looks exactly the same over and over. Now, the pattern that we look at might vary. You can kind of see it in this example down here. In this black colored pen here, you can tell that we are looking at one cycle as going from the top of one piece to the top of the other. However, we can also look at the cycle from a different place. Notice in this blue pen here, as I trace over what this other cycle looks like, it's still considered a cycle because it's still copy paste. However, it looks different than that black pen. So periodic functions are the same pattern, but the pattern that might stand out to you may look different than it does to someone else. But the key thing is here that the pattern stays exactly the same. It's not getting bigger, it's not getting smaller. Now, what we call that pattern is we actually call it a cycle. So one cycle in our periodic function is when we see a complete pattern. So in this case, either that black or the blue there are both considered a cycle. And that cycle that we care about will be repeated over and over and over again. Now, the length that that cycle lasts is what we call the period. So our period is how long our cycle actually goes. So it's this horizontal length of one cycle. Now, oftentimes when we think of horizontal lengths or things like that, we think of our X values, which are typically time when it comes to an application. So that's exactly what's happening here. We are looking at the amount of time that our function lasts for that one pattern. So looking at our one pattern here, our one cycle, how long does it last? Well, for this one, you can kind of see that it goes 2, 4, so this looks like it kind of starts here, it ends there. You can kind of approximate. If I wanted to start in this middle piece here, I can see that it goes up, down, down, up. Before I go to repeat that next section, which would be right here, it looks like it goes from 2, 4, 6, a little past 8. So in the case of this one would be about 6 and a little bit is how long the period of this is. Now, depending on what the function looks like, the period can totally vary. A lot of the times when it comes to application questions, we deal with trig functions. So their periods are typically in terms of radians or in terms of pi. So keep that in mind as you look at these. They're either going to be whole numbers or pi, just depending on what we're doing. So those are some key characteristics there. Now, in addition to those, we also have some other characteristics that we really care about when it comes to periodic functions. We care about the maximum. So the maximum is the highest point. The minimum, on the other hand, is the lowest point. The midline is the line halfway between the maximum and minimum. So if I have a function that looks like this, our maximums would be up here. And notice how there is definitely more than one maximum. Our minimums are going to be down here. And remember that our function is going to look exactly the same, right? So it's going to keep going in the same way forever. Our midline is going to be the middle between those two. So the way that we find it is we actually can calculate it by adding the maximum y value plus the minimum y value and dividing it by 2. So in this case, I would take this value plus this value and divide it by 2. And you're going to see that it ends up giving us wherever that middle piece is, and it divides it exactly in half. Now, the other piece that we care about is something called an amplitude. So depending on our application of our periodic functions, the amplitude makes a big difference. So if you're thinking about music or something like that, a vibration pattern, something that has a lower vibration pattern or a lower amplitude typically produces a lower sound wave, right? A lower sound. However, something with a higher amplitude typically ends up producing a higher pitched sound. So we really care about what those different things are. And again, the way that we calculate that amplitude is we are going to take our midline and we're going to figure out that distance to our maximum or that distance to our minimum. Both of those should be the same from our midline because of the fact that our midline is exactly in the middle between that maximum and minimum. So our amplitude should be the same going both directions. But if you wanted to calculate it by hand, the way that we do that is we take our maximum y value, we subtract our minimum y value, and we divide the whole thing by 2. And that's how we find that. So let's go ahead and take a look at some examples of how we can look at periodic functions here. So let's start with this first one. So they want us to identify one cycle in 2 different ways on this graph, and we want to color it. So I'm going to start with blue. One cycle that I see is going to go from top down up to top. Now you can see that that first cycle there, it goes from top down, top. After that, I can copy paste that or trace right over it, as you can see here in green. And I can just shift that and notice how it lays exactly on top, a copy paste sort of situation. Now that is one way to look at that. However, another way that a lot of people look at it is when it's a function like this, some people will start here and they'll actually count an up, down, and up until they hit that midline, until they hit that midline again. Woof, English. Okay, so with that idea, it's exactly the same. So if I wanted to take that up, down, up, I can shift it and copy it anywhere that I want it to be, right? Overlap here, overlap here. I know that it's going to look like this over here. And you can see how that pattern follows exactly the same way. So that would be our cycle there. If we look at this second one here, our cycle, we can draw it two different ways. We can go bottom to bottom. We could go top to a top. We could also go from like, I'm going to use purple here. We could go from like a middle to a top. Any of those different patterns there are what our cycles would be. So make sure that you're being aware of our cycles and including them, because that really makes a huge difference as to what our periodic function does. And those cycles make a huge difference in the application of stuff. If you're thinking about a heart rate or an EKG, those patterns that you see on that periodic pattern will make a huge difference as to whether or not a patient is healthy or not. And that's something that we all care about and all want to know, right? Okay, let's take a look at this next one. So we want to determine whether each function is periodic or not. If it is, find the period. Okay, so remember the period is how long the pattern lasts. So how long our pattern lasts. So if our period is how long the pattern lasts, what we want to do is see, is it a copy paste pattern here? So if I look at this first one, my pattern or my cycle would look like this. Now, if I traced back over that and I just shifted it to the left or right, does it match up? No. Although it matches up going up and down, it has to be a copy paste in exactly the same location, right? So if I just move this straight over here, it doesn't look exactly the same. So this one is not considered periodic because that pattern is not copy pasted over and over. The one on the right here is, however, considered that copy paste. And you can see that it actually looks a lot like the one that we had before. So in this case, I'm going to do mine from a top to a bottom. And I want to know how long, or from a top to a top, and I want to know how long that lasts. So you can see that I started right here at x equals -2, and that pattern ended here at x equals 2. So what that means is our period, or how long it lasts, ended up being 4 x values. So we would just say that it has a period of 4. Now, if this was application, that could mean 4 minutes, 4 seconds, 4 microseconds, whatever you're measuring and whatever you care about. But that is how that works there. Okay, let's take a look at a couple more examples here. So if we want to find the amplitude of each function, remember, we talked about how we can calculate amplitude. Amplitude is calculated as the maximum minus the minimum divided by 2. So if we want to calculate our amplitude here, what we want to be able to identify is our max values and our min values to start. So my maximum value is the highest y value that I see. In this problem, it looks like that would be at 1. The lowest value that we would see is at -2. Now, a reminder, you can always look back in your notes, but our amplitude is the maximum y value minus the minimum y value. We are looking at this piece right here. So with the idea in mind, we've got max minus min divided by 2. So I'm going to take my maximum value. I'm going to minus my minimum value. Remember, we're subtracting a negative and dividing it by 2. So 1 minus -2 is the same thing as 1 plus 2, which is 3 divided by 2. Or if you wanted to write it as a decimal, that would be 1.5. So you can see here that our amplitude is 1.5. So that means from wherever our midline is up until the top and up until the bottom is going to be at that 1.5. Now, if we wanted to find our midline's probably going to end up being somewhere like this. And again, we can calculate that by doing our maximum plus our minimum divided by 2. And when we do that, 1 plus -2 is -1 divided by 2 is a half, -0.5. So really we know that our midline is going to be at -0.5, and that distance from this number to our max is 1.5, and this number to our minimum is also going to be 1.5 there. So I want you to take a chance. Feel free to pause the video, go through and try this next one, calculating that amplitude on your own. Remember to identify your maximum and minimum. When you've finished with that, feel free to unpause the video and double check to see if you agree. Okay, hopefully you have done this one already. What we're gonna do here is we're gonna look at our maximum and our minimum. So our maximum point on this one is going to be, well, if this is 4, this is 2, that must be 3. Our minimum value is going to be right around 0. And remember, we calculate this by doing our max plus our min, or minus our min. Ooh, that's how we calculate amplitude. Awkward. Or sorry, that's how we calculate the midline. We want to calculate the amplitude. So we're going to do the maximum minus the minimum divided by 2 to figure out what's that difference there. So we would take our 3 minus 0, which is just 3, divided by 2. And that would give me 1.5 again. Now, if we wanted to calculate that midline, this midline would be in a different place. We would have 3 plus 0 divided by 2, and we can see that that actually occurs at 1.5. So if I went through and I put a line here at 1.5, you can see that that's about halfway between this and this. So you can see how that works there. But if you were calculating your amplitude, our amplitude in this case is 1.5. Now, just to put the cherry on top, we are going to do 2 examples where we identify all of the characteristics, just as a reminder. So this first one here, we want to identify the cycle, max, min, period, midline, and amplitude. Wow. Okay, let's start by doing our cycle. I'm going to just color my cycle on in green. Now, I typically, if I see this wave sort of look, I like to start at the middle and get the down, up, down. You could also start at the inside here and go up, down, up, totally up to you. But remember, our cycle can be drawn a lot of different ways as long as that pattern gets repeated over and over. My maximum value in this case is going to be at 2 with my minimum value at -2. And you can kind of see where those are. Now, our period is how long our pattern lasts. So if I start here at -3 and I stop here at +1, from -3 to +1 is 4 units on my x-axis. So I want to make sure that I'm using that. Now, our midline we talked about as being the middle between our maximum and minimum. So if we want to calculate that, we are going to do our maximum plus our minimum divided by 2. So in this case, we would do 2 plus -2, which is 0, divided by 2 is 0. So up here in blue, I'm going to put a line at our midline. Notice how that is right down the middle. And in this case, it's at 0. Now, our amplitude is the distance from the max to the midline or the minimum to the midline. So the way we calculate it is we just do our maximum minus our minimum divided by 2. So in this case, we would have 2 minus -2 over 2. 2 minus -2, we know turns into a plus, and we end up getting 4 over 2 or 2. So what that's telling us is this distance right here is going to be a distance of 2, which seems to make sense, right? That that's all equal from the max to the midline or the minimum to the midline. But that's how we identify those. So if you have any questions, don't hesitate to reach out. But that is periodic functions in a nutshell. So again, as a reminder, a periodic function is one where the same pattern is repeated over and over. A cycle in that is one of those shapes of that pattern. So being able to recognize that. The period is how long our pattern lasts. From there, we can identify other characteristics like the maximum or the highest y value, the minimum or the lowest y value, the midline, which is halfway between our maximum and minimum and calculated by doing the maximum plus the minimum divided by 2, and our amplitude, which is the distance between our midline and our max or our midline and our minimum. And that's calculated by doing our maximum y value minus our minimum value y value divided by 2. If you have questions, don't hesitate to reach out. Thank you.